Hello everyone, my name is Joshua Maddox, and this is my video for the quicksort algorithm. For the quicksort algorithm, you first start with an array of integers that are unsorted. As we have here, we have 8 integers that are all out of order, and we'll be putting them in order from least to greatest. The keys to quicksort is you will have a pivot, a counter, which is J, that will keep track of all the integers in the array, and your placeholder, and you'll have a variable I, which will be your wall, which will keep track of the sorted elements in the array. For our pivot, we will select the rightmost element in the array, which is 5 in our case. So for our first loop, we'll have our pivot 5. Our wall I will be in a spot 1 less than the least integer or the leftmost integer, and J will be the counter, which will be placed at the first integer. For every step, you'll select J and the pivot, and compare the two. If pivot is less than J, then you will do nothing and you will keep this element in the array where it is. If the pivot was greater than J, then you would implement the quicksort algorithm. But since J is greater than the pivot, we do nothing and we implement J plus 1. Now we see that J is less than the pivot, so we implement I, we increase I by 1, and we swap J and I and put them back. And then we move I and keep I in this spot, and we increase J once again. We see again that J is 2 and our pivot is still 5, so it is less than the pivot, so we do the same function. Increase I, swap the elements, keep I in its place, and increment J to the next element. As we increase through the array, we see our next element is 4. So once again we increase I by 1 and swap the elements. Once you have fully incremented through the list and J and the pivot are the same element, then we will take our pivot and insert it to the right of our wall. The key to the quicksort algorithm is to partition our array into 2 separate subarrays, which is a divide and conquer method, which will be easier to sort our array. Therefore, we found the place in the array where our pivot belongs, and we have 2 subarrays. All the elements to the left of our pivot are less than the pivot, and all the elements to the right are greater than the pivot. That way we don't have to sort anything to the left of our pivot anymore, and we don't have to sort anything to the right to our pivot anymore. We treat them as separate arrays. So to continue sorting, we will take our separate arrays and sort them using the same method again. So we will place I to the left of our first element. We'll place J at our first element, and we'll select 4 as our pivot. 3 is less than 4, so we would increment I, and we don't have an element swap it with, so we will leave 3 in the same place and increase J. We'll do the same function, swap these two elements and increment. As we see here that 4 is the greatest element in this array, therefore this subarray is sorted, so we can put them back in the list. Next, we do the same thing with the second half of the array. We'll select 6 as our pivot. J is our first element, and I is to the left of our first element. We see that 9 is greater than 6, so we do nothing. 7 is greater than 6, so we do nothing. 8 is greater than 6, and now we're to the pivot, and we place our pivot in the element to the right of our wall. So now we know that 6 belongs here, and we still have another subarray that we can sort. Once again, place our pivot back, and we repeat the same steps. So 9 is greater than 8, so we do nothing. We move to 7. We see that 7 is less than 8, so we increase I, swap I and J, and increase J. We see that we're now at our pivot, so we take our pivot and place it in the spot to the right of the wall, and now we see that this side of our subarray is also sorted, so we can put it back into order. And as you see, our array is now fully sorted.